starting off, obviously some of the perspectives that we have with regards to problems that we run into is recalls. Product recalls affect us. They affect all aspects of the industry. This, for example, is the big recall. This is a 10 million pound recall that's happening right now with regards to the 90157s, which are new adulterants in the beef industry. So what do we consider when it comes to food safety and quality issues? Obviously, I have 4 things listed here. Foreign objects are big: shelf life, spoilage, allergens, residues. Those are all things that we take a look at. If you take just these 4 categories here, I went back for a few years, from 2011 to year to date. There was 198 recalls for those above mentioned issues. So obviously the packer perspective is really about control and how we can prevent those types of things happening. However, without a doubt, controlling microbiological contamination is the #1 priority for packers. We got to get control of these bugs. These organisms are part of our business, and we just have to find ways to try to prevent them. So looking back from that same time frame, from the recalled products due to microbiological contamination, you can see the poundage there with the 0157H7. Obviously, is an adulterant. Now the new S-Techs are adulterant in the beef industry. Salmonella, Listeria, and then rounding out the bottom is a staff recall for a whopping 77 pounds. But at the end of the day, if you look at that number, 14 million pounds, that's pretty staggering when it comes to all the products that are affected on over the last several years. So today, what I want to talk about, what do we do in the facilities to control these organisms? I want to go through some of the intervention strategies that we incorporate, looking at pork, chicken, as well as beef. Beef's going to have a little bit more detail for the simple fact that we have some challenges because we are controlling an adulterant from the time it comes in to the time that it goes out. So I'll put a little bit of emphasis on that. What happens when you pressure that system? When you have an incoming load that you can't control very well, what does it do to our process in the plants? And then when that system gets overwhelmed, what happens when you have a large variety of organisms that come in and you can't control them in the system? What has to happen with the product that you produce from that? So getting into it, the foundation of the best practices and regulatory compliance. The bullet points up there, they talk about good dressing procedures from the beef side is obviously important. Monitoring those programs with the harvest activity through the microbial activity. Optimizing interventions. When I go through the intervention systems, you'll see that it's not something that's stagnant. We try to find the best intervention to put in place depending on where we are, but we're always trying to improve those areas. Robust sampling. They do carcass sampling for all the different proteins. Beef, we do a little bit more. Pork, we do some monitoring throughout that process, and then poultry every once in a while just to make sure that the system is working as intended. And then, of course, we do operate under the fully implemented HACCP plans as well as sanitary operating procedures from a regulatory standpoint. So the multiple hurdle strategy, that's what we use to incorporate into all of our systems, regardless of the protein. In addition to visible contamination, we have to remove that bacterial contamination, which obviously is, through the naked eye, can't necessarily be seen on that particular carcass. So the use of those repeated aggressive interventions, you're looking for those specific organisms at critical control points through the process. It's part of HACCP. That's really what HACCP is intended to do, is you look into your system and you say, okay, where are the control points that I have to implement something in order to control the target organism that I'm looking for. And then the added benefit of staggering the interventions. One of the things that is challenging is if you have an intervention that may have a 2 or 3 log reduction and then you follow it up with another one with a 2 or 3 log reduction, that doesn't necessarily mean that you have a 6 log reduction of the whole system. You have to find out what each one will do from validation and verification, and I'll talk about that in a little bit. But then you also have to look at your whole system as what can you do from start to finish. So the goal of intervention system, these are obviously, for effect, fairly exaggerated pictures, but really what we're trying to do is we're trying to prevent the contamination from the outside of the animal getting onto that carcass as we go through that process. I'm not sure that there's a lot of pigs that look like that when they get into our facilities, but again, we're trying to make sure that when you do have problems that are on the outside of that hive, that you can control them through that system. So getting into the pork food safety model, again, as I mentioned, multiple hurdle approaches. We look at the slaughter floor primarily when you're speaking of food safety from a raw processing standpoint. It's the slaughter floor that you're going to have the majority of your intervention steps in. In my opinion, I think pork is a good system because you basically singe the surface of that animal as it goes through the process. At that point, you're killing the majority of those organisms. So you have that external thermal sterilization, which is that singe step. Then as you go through the finishing of that slaughter process, you use things like steam vacs before and after the carcass chill. And then the implication of, or the addition of lactic acids and organic acids that you can use to decontaminate for anything that may happen through the remainder of that slaughter process. Moving on to the cold chain management, whether it be beef, pork, chicken, whatever that is, you have to have good cold chain. When you're talking about carcasses that have to chill, the longest time that they're going to stay in that plant is going to be during the chilling process. So you want to make sure that you have good cold chain, you get those carcasses cold, such that you can reduce the bacterial activity and the growth of that through that process. The microbial monitoring of the pork side, again, as I mentioned, they don't do as extensive as we do on the beef side, but we'll pull micro samples, looking at just general orbital plate counts to kind of give us an idea of what's coming through that system and how well our intervention system is doing as a whole. As a rule of thumb, we'll pull them a couple times a week, and then they'll use that for tracking and training purposes. I have an example a little bit later to talk about how we use that a little bit more efficiently. Generic E. coli sampling, that's part of the government regulations that have to be done on both beef and pork when it comes to making sure that the levels of generic E. coli are low enough that you're not seeing any problems or would indicate any problems of your slaughter process. And then in process in conjunction with the cold chain management, just to make sure that from a product quality standpoint, that you're not having a tremendous amount of bacterial activity that's going to affect the quality of that. That's big on the pork side. So then moving into the poultry, you get into it's a little bit more complex, where you have more intervention spots throughout that system. Over the next couple slides here, I'm just going to be covering kind of the main points and some of the areas that we use when we get down to the antimicrobials in different areas. But starting with the live side, receiving, you're going to try to prevent cross-contamination with the cages. You want to keep them clean, you want to keep them sanitized. The defeathering, we'll use hot water and chlorination during that process. The washing of the carcasses, you can obviously use chlorine. Peroxyacetic acid is a big antimicrobial that is used in the poultry processing. The inside washer, as listed there, high pressure, high volume wash with chlorinated water and application from a processing aid standpoint that they'll use for that inside wash. Brush scrubbing, it's a little bit different, high volume, low pressure, but again, antimicrobial application, as well as then the brush scrubbing in itself is part of reduction of that process. Then you're getting into that final wash, you're starting to use your 50 parts per million free chlorine. Sodium bisulfate is another chemical that they'll use for that contamination. Whether it be a finishing chiller or a post-chill spray, the finishing chiller, you'll have 30 seconds application of real high peroxyacetic acid is one of the chemicals that we use in a few of our facilities. Or the post-chill spray that they'll use that CPC up to 8%. So that'll be basically from the start to finish when it comes to the poultry, from the raw side. And then poultry and pork as well. Then you go through the cooking step into the ready to eat. I didn't put too much focus into ready to eat in this particular talk, but there's obviously that process of making sure that the environment is kept clean, that you're not having bacterial contamination in those particular areas. So getting into the beef food safety, as I mentioned, beef food safety, in my opinion, is unique. You are controlling that adulterant through that system, and one of the things that we've incorporated at JBS is what we call the SAFE program. It's nothing more than the Slaughter Actions for Excellence. We've defined these major impact areas that have some spillover of kind of what I just went through from an intervention standpoint. But looking at these three, basically the carcass dress, mechanical intervention, and microbial monitoring, are those areas that we put focus into to try to control that system from the start to finish. So this slide really talks about, I guess, what I would consider the three truths of the slaughter process. And basically, when you dress that carcass, that you can't dress it without transferring some type of bacteria onto the surface of that carcass. And I think that's an important piece to understand, because you do need a mechanical intervention system that's going to help reduce any contamination that you do get on there. However, you cannot implement a mechanical intervention system strong enough that's going to overcome a poor dress job. So if you get too much on there, you got to have your mechanical intervention system is not going to be able to control it. So you need to have both. You got to have a robust dressing procedure, make sure that you're reducing the amount of cross-contamination, and you need to have a strong mechanical intervention system that's going to control it once it does get to that point. So looking at that carcass dress, basically there's four areas that we put focus on. Critical job monitoring is, are the employees doing their job right? It's not a complex step. We have about 6 functions that they have to do, so we audit to them to make sure that they're doing it correctly. Contamination audits, how much visible contamination is getting onto that carcass that we can see and we can audit. Carcass spacing standards, as I mentioned, The carcasses are going to be in the coolers the longest amount of time. Bacterial growth is really about time and temperature. So if you get good airflow, you get the surface of that carcass chilled down in enough time, then you're going to have much less bacterial activity that's going to grow up in that cooler. Folds and flaps. What that is when you dress that carcass, if you create a cut or a flap on that carcass that bacteria can get into, what that's going to do is that's going to impede the effectiveness of your mechanical intervention system. Bacteria is going to embed in there, you can't get it out, then your mechanical intervention systems aren't going to work. When you get into fab and you make trim out of that product, you're going to find it in your trim and then subsequently into your ground beef. The carcass dress, it's really about focusing on prevention. The easiest way to keep the bacteria off is to leave it on the hide and not get it onto the carcass. So the dressing audits are put in place, and we monitor the SOPs to make sure that's exactly what we're getting to be done. The auditing system that we put in place, we enhance that with cameras. So we use Aerosite is a third-party auditor. It's called RVA, and all that stands for is Remote Video Auditing. And we're able to have cameras put in certain locations throughout the kill floor. And what we can do then is it records everything, but we're able to audit it at various times of different jobs or critical jobs throughout that process, so that we can get an idea of basically what's going right, or if there's areas that we need to improve upon. It's unbiased and performed by a trained field technician. We still have auditors come out and they'll stand next to the employee and they'll make sure that they're doing their job right. But we like to also watch and use the cameras because it's not so much a big brother thing, but it's more of a training tool. So if we identify an employee that may not be doing his job correctly, we'll bring him in, show him what he did wrong, we'll make sure that he understands what he's supposed to do, and then we'll put him back out there in order to do it properly. So where do we use the RVA? Well, we use it in two main areas, monitoring the critical jobs, as well as looking at the cuts, holes, and flaps. So it's really about a behavioral change. You want the employees to understand that they're supposed to be coming in, and they're supposed to be doing their job right each time. And if they're not doing it, then we just have to identify that, and then we can get them to do it right. Very few times have we found that anybody comes in and just maliciously does their job incorrectly. Most people want to do it right. It's either that they just simply made a mistake, or that they haven't been trained properly. And if they haven't been trained properly, then that's our fault. That's not the employer's fault. So we just need to identify those people and get them back. The cuts, folds, and flaps is how well, if you make a mistake and you make a cut in that carcass, how well you've reconditioned that prior to the intervention system, such that you just don't impede the effectiveness of that. So then getting into the mechanical intervention system, basically you have two areas: the slaughter floor, which is where most of it happens, and then we do have some on the fabrication side, which I'll walk through here in a little bit. So in general, some of our plants have hide washes, and that's really nothing more than trying to get down as much surface contamination on that hide as possible. Some of them, they're not massively effective. I think that we need to do a little bit better job in investigating some of the techniques that can be used. If you guys are around tomorrow, I'm giving another talk here at the end that talks about some of the things that I think the packing house needs to do a little bit better, is investigate that area of the business and how we can improve that. After the hide's been removed and it goes through a pre-wash, we utilize a lot of hot water in our facilities. I think hot water works great. There are other interventions. People have used lactic acid, they've used bromine technologies in those areas. Moving through the kill floor, then we get into our final wash, and again, in our plants we use hot water. It's basically just a big cabinet. We put about 1,200 gallons of 180 degree water on the carcasses, and we like to get them into those cabinets for at least 10 seconds at 170 degrees, which we found to be quite effective when it comes to reducing organisms. We are looking at putting bromine in our bone washes, which is prior to the cabinet, to try to reduce that level before it goes into the intervention system. We do use lactic acid after the cabinet as an additional antimicrobial before going into the chilling system. As I talked about before, the chill, you need to get them cold, and you need them cold as quick as you can for the best effectiveness. After the chill process goes into the cold spray. Treating a cold carcass is a little bit more difficult than treating a hot carcass. The intervention that we found to work pretty well is lactic acid, at least as far as the best that we've seen. So the cabinets that we spray going into our fab, we use lactic acid. Sub-primal sprays, we do the same thing. We have used a peroxyacetic acid on the beef side. Lactic acid, we found to work just a little bit better. The sub-primal sprays, it's even more challenging because they go through so fast. You're only looking at about an application of about 2 to 5 seconds. What we try to do is spray from the top and the bottom. If you see that belt there, that's a mesh belt, so we try to get as much coverage on the bottom side as possible, but it's a difficult piece of meat to treat. Then finally, the microbial monitoring of that. We call it our harvest monitoring program. What we do is we look at 7 different areas throughout that process, starting from the hide all the way through the kill floor and then into the coolers. Looking at the various steps there, you have your hide on, then you're prior to any intervention system after the hide's been removed, your post-evisceration, and then prior to your final wash, which is where you'd have that pasteurization, lactic acid, and bromine at step 4 there. Step 5 then is after this, what we call our main CCP, which is that particular wash, and then just before the hot box. Then also we pull a sample after the hot box because we want to monitor what that activity in the coolers are. We try to utilize the same carcass through steps 1 and 5, such that we can have a little bit more power when it comes to running our statistical models. But it's difficult once you get past step 5 because we end up losing the carcass in the coolers. So then we pull a different carcass and we go through steps 6 and 7. So we kind of have a good model of what the cooling process looks like. We have a good model of what the slaughter floor process looks like. So that's basically what the beef intervention system looks like and how we collect some of that data. Regardless of where you're at and how you implement a system, it's very important that you have validation and verification that your system not only reduces the microbes, but then once it goes through, that it's continuously doing what it's intended to do. So all effective systems are going to have validation and verification. And validation is really to demonstrate that can they control microbial contamination. So if it gets on there and it goes through a system, then is it working? And we look at it, you can do it in 2 different ways. We historically have looked at it what we call uninoculated samples. And you can see that basically here is all you do is you pull a sample before that intervention, and then you let it go through the system, and then you pull a sample after the intervention. You look for the reduction of the organisms, and that's what you find. And that's fine. I'm not implying that doesn't work, but sometimes you have the big, powerful intervention that you know you can get more out of it than reducing it 1.4 logs. So what we started to do is we started using surrogates. So there are developed surrogates for 0157 as well as for salmonella. We can go in and we can inoculate the carcass, we can run it through the system, and then we can really see what the effectiveness of that intervention can do. And that's been a pretty powerful tool for us because now that we know what it can do, then we can start building from there as what does that overall system need to look like. So again, there's just a couple of different ways, and there's a lot of companies out there that are still doing it just with indigenous organisms, and like I said, I think that's fine. But we found inoculated studies have worked pretty good for us. So verification really is you're measuring the effect of an antimicrobial treatment or the effect of an intervention system. So you can look at it at an independent intervention, or you can look at that system as a whole. The way that we do it is we use our beef trim, or our beef trimmings that we test for 0157. So a little bit of background. Basically, all the trimmings that come off of the sub-primals as they're fabbed through that carcass, they go into these big 2,000-pound combos. All those combos are then produced into ground beef. Every one of those combos we test for E. coli 157. So when we get positive test results, as mentioned there, we'll start with the negative test results, indicate that your system is working. So whatever you did from the start of your process to the point that you made it at the end into that combo, the system worked as it's intended. When you get a positive test result, well, that indicates that something went wrong, and it's often difficult to determine exactly what went wrong. But what that means is that you need to have some investigation into your process. You need to go back, you need to see if you can find the root cause, and if you can't, you need to try to find and implement what we call process improvement. So anytime that we get positives, we're always implementing process improvement, because you can really go out there and make the system better every time that you find that it's not working as it's intended to. So pressure on the system. What happens when unknown incoming loads come into your plant? Well, what we try to do is at steps 2, 4, and 7, what we try to do is we've tried to set limits for what the bacterial activity of that carcass is going to be at those specific locations. So as mentioned here at step 2, we want less than 2 logs from our general bacteria. Step 4, less than 1.5. Step 7, less than 1. What that tells us is that we know that through our validation studies that if the organisms come in at those levels, we can control that process. Let's see here. The challenge comes is that when you have incoming loads that may fluctuate, what we found is that look at this graphic. So this is the incoming load of the hive, and this is the load that's transferred to the carcass prior to the intervention system. And unfortunately, what we found is that when that pops up, it's pretty much related to what happens to the surface of that carcass. Now, intuitively, that makes sense, but what happens is when we don't know when that happens until after the fact. So if we're trying to manage it here and we don't see that spike till a couple of days, that can be problematic for us. We did just some statistical analysis using the 2-log model, and what we found was when we had E. coli positives on days where our pre-intervention carcasses were greater than 2 logs, and then we looked at it at days where we had it less than 2 logs. And what we ended up finding here is the likelihood of a positive is higher by 106% when the APC count is greater than 2. Now, does that mean that if you have a log on your carcass prior to intervention system greater than 2 logs that you're going to have a positive? No, it does not, but the historical data that we used suggests that when you do have it higher, that your chances of getting a positive is greater. So obviously, going back to this graph, if that's the case, likelihood is greater than 2 logs. When we get into these areas, this is something that's manageable. If that's what we see on a normal daily basis, we're in good shape. If we kick that up and you see that incoming load increase, then this can be problematic for us. And what we really need to do is find out ways that, regardless of what this line looks like, that we can keep that at these levels. Ultimately, we'd like to find strategies to prevent this from happening, but at this point, we need to try to figure out how we can get that line to stay straight. So getting into the last section here, I know we've got a hard stop at 3:05, so I'm going to rip through this one pretty good. 5 minutes, got it. So what happens when the system gets overwhelmed? Well, we look at it what we call THREATCON levels. So basically, when you have a normal day, everything's clear, everything's negative, no problems. Alpha, you have a single positive in your trim. We test on a big plant, about 400 combos a day. So you have a single positive, it's a glitch in your system, probably nothing went wrong. It could be just an anomaly. So we pull that one out, we send it to cooking, and then we move forward. The Bravo side, so we look at multiple sporadic positives, meaning that you have more than one positive combo throughout that day. So chances are you're going to be pulling in some associated negative combos. They may be the same lean point, they may be produced during the same time. You have Charlie, that means where you have many more positive combos than what you would typically find. So then there's indication that it may spill over into your subprimals. So we don't do any testing of our subprimals, but if our trim loads are high enough, then it may have to indicate that there could be some cross-contamination to our subprimals. Then there's the delta day, and I'll have an example of that here when we move forward. That's when everything goes wrong. So the THREATCON Bravo, here's an example. You have 4 positives at 156 lots. What we do is every combo that we collect, we do have a bin in time when it started filling and a bin out time when it completed filling. So what we can do is when we have our positives, we can go through and we can determine a time frame onto which would be contaminated product. And we can go back, we can collect everything that needs to be collected and associated, send that off to lethality, everything else can then ship. When you have more positives, as an example, 36 out of 38 presumptives, 38 total positive combos, 36 of those were between 7 and 1030. So what we need to do here is we have to look at where the affected product was produced. So basically time and space. What was the product mix? 50, 65, 85, sirloins. And where did it come from? Well, the arm line, rough meat, round line, strip line. So now you're beginning to isolate where all the product came from and what you need to do around it. So from here, then you look at the time frames. So basically, from this point, from about 11:30 on, would be subprimal time frame would be effective. As I mentioned, there were so many that could indicate that there could be problems with your subprimals. However, everything after that, even though we had some isolated positives, subprimals would not be effective because it's low enough to indicate it's just the trim, it hasn't spilled over to your subprimals. Then the delta. So here's an example. A few years ago, we had 114 presumptives out of 429 tests. 26% of our trim was positive. That was a train wreck. I mean, basically everything went wrong, and the whole day kind of blows up. And this is what by hour-to-hour basis looks like. And at this point, the entire day is affected. So you have to find out where all your product is. You got to bring it back. You either treat it or send it to cooking. It doesn't happen very often, as a matter of fact, very infrequent. But it can, and really what you need to do is when that system is overwhelmed, you got to take the initiative to control it because you can't get that stuff getting out into commerce. So for the last 2 minutes, never lose sight of the basics. Basically, good GMPs, good SSOPs, and HACCP assessments to prevent those issues that occur. You must have a strong intervention system in place. You know, again, 3 truths of the harvest. You can't dress a carcass without cross-contaminating some bacteria, so you got to have a strong intervention system put in place. When pressure is put on the system, it's very important that you identify the affected product and you control the movement of that product. You can't let it get out into commerce. You're better off throwing that net wide and then backing it out rather than letting it go and then trying to pull it out when it's in place. And never be complacent. We're always looking for improvements. There's a lot of good technologies out there. There's a lot of new stuff that we can be trying. So we gotta investigate those things and see if we can find out what's best and what works for you from an economic standpoint.